As mentioned, I'm here to talk today about an exciting new project that we're working on here at Red Hat called RamaLama. And what we're trying to do is we're trying to make AI boring. And hopefully through this talk, I'll share with you about how we're trying to do that. So really quickly about myself, as mentioned, I'm a product manager at Red Hat for Red Hat Enterprise Linux. I manage the high performance computing and AI offerings for RHEL. But prior to Red Hat, I was actually a chip designer, a chip design engineer, worked in computer networking, industrial automation, did spend a little time doing neurotech, medical device prototyping. So if any of those things are of interest to you, I love kind of chatting about those topics. So please feel free to come up afterwards and chat with me about those if those are interesting to you. So I think there's a lot of AI is a really interesting space right now, right? I think there's a lot to be excited about, a tremendous amount of innovation, right? I also think that there's a lot of aspects of AI that are maybe negative exciting or negative fun. So things like the technology stack kind of is really hard to use or hard to get up and running or breaks consistently. Things around kind of security, data privacy, right? This kind of these surprises of like, hey, surprise, X, Y, or Z was using data that they didn't have access to or didn't have permission for. And so with RamaLama, we want to put everyone in that top right-hand quadrant of help you to experience the excitement and the fun of AI, but limit maybe some of the, where possible, like the negative exciting and negative fun sides of it. So what is RamaLama? RamaLama is an easy, secure, and open way to run and serve large language models locally. And it's all done the container way. So I want to get a kind of quick show of hands. Raise your hand if you've ever experimented with a large language model. So play with the ChatGPT or whatnot. I think that's most folks, right? Okay, hands down. Have you ever run a large language model locally? So have you run it on your local machine, a laptop or whatnot? Cool. Most folks. Hands down. Raise your hand if you've built an AI-powered application. And what I mean by that is like an application that has a generative AI model in it. Yeah, a few folks. Great. So I think RamaLama has a lot here for you, whichever stage you're at. And we hope to make it easy, secure, and open. How does RamaLama make it easy to use? Well, with one simple command on the command line, RamaLama is a command line tool, you can run or serve a chatbot. So, a couple months ago, many of us have heard about the news around DeepSeek and, amazing new technology, as well as kind of a lot of questions about how they built the model, how they used, their accelerators. For me, at least, I was very curious about okay, well, what is this thing, right? Well, with one easy-to-use command, RamaLama run DeepSeek, you can check it out for yourself and see what this model has to offer. The second piece is that it's secure, so you can experiment with these large language models while keeping your data private. And I think this is a really big thing because when I talk to customers or I talk to even just kind of friends casually about where their organizations are at, in terms of using this really great technology to make us more productive or help us with our work, I hear a lot of folks say yeah, we're still trying to figure it out, or we're very sensitive to exposing our organization's data, especially to a cloud service or an AI service. And so in using RamaLama or a tool like RamaLama and running it locally, you can know and have confidence that your data is not leaking out to someone that you don't want to give it to, right? And then finally, RamaLama is open, so it's built using open standards and AI building blocks. It leverages a lot of kind of the existing ecosystem of open source technologies that exist in the AI space that's driving a lot of innovation and also kind of makes it accessible to many of us. And so RamaLama really leans into that open source ethos and those building blocks to make it easy to run. So now I want to talk a little bit about like why we built it on containers, and the reason why I bring this up is not to necessarily like, oh, I love talking about containers, even though containers are great. But it's more so that it kind of explains why we think RamaLama is like a really great, like easy, secure, and open solution. So first and foremost, it's built on a container engine. So and you can use Podman, you can use Docker, whichever container engine that you like. What this means is that RamaLama is actually available and usable on any operating system platform of your choice. So you could run it on Mac OS, you could run it on Windows, you could run it on any flavor of Linux. Today, RamaLama is packaged in Fedora. It's also available in the Apple repository for Red Hat Enterprise Linux users. So that wide availability is, we think is really great. And then the second is that, it pulls in, so RamaLama pulls in the relevant container image. And why this matters is because, it's really kind of hard to get this stack up and running, right? And so it will pull in a relevant container based on, which accelerator stack, or if you don't have an accelerator, like what is the most appropriate kind of configuration for your system, and just abstracts that complexity for you away so that you don't have to worry about it, right? You can just worry about, hey, I just want to try this model, and that's great. And then finally, you can take that model and the whole stack of that you want to run or serve as an API endpoint and deploy it to an OCI container registry. OCI is Open Container Initiative. It's like a set of standards for containers. And we think that a lot of organizations basically already have adopted this sort of practice for containers. And we want to make it such that it's like, okay, well, plug into the world that you already know. Let's not go and create something new. And lean into the container registries that you already are very familiar with. Okay, so I want to take you back to a time, because I know most folks here have already experimented with large language models, but I want to take you back to a time when maybe you were still learning about it, right? If you can think back to maybe years ago, or maybe that's even fairly recently, and like when you were really curious about what this technology had to offer and you wanted to try it out for yourself. Well, one of the first things that you may find is that, so you may have heard of Hugging Face, which is like one of the most popular model registries that are out there. A model registry, you could think of it as basically like GitHub, but for models, right? So it's a public place where people can post the models that they want to make available and share with other folks. So you may have heard of, like, say, the IBM Granite model, and you're like, hey, okay, I want to go to Hugging Face, I want to get that model, and you go and look it up. And I know this situation happened to me not long ago. I was like, okay, go find Granite on Hugging Face, and then you find pages upon pages of different variants of the Granite model. And there's different quantization methods, there's like different parameter sizes, alignment techniques. And for someone who is just getting started, right, like that can be really intimidating. Which one of these should I use? Like I have no idea. I have no idea what any of these things mean. Like why does it feel like I need to be an AI researcher in order to be able to try this out? Well, with RamaLama short names, we make that really easy. So for example, you can see here, like you can run RamaLama run Granite, and it'll pull the most common version of Granite, of the Granite model. And it's just that easy. You don't have to think about all these different permutations and of techniques and variants that exist. So you can just try it out as quickly as possible. But of course we know, like, these techniques matter, and these like different kind of parameter models matter as well. And so of course you can provide it kind of the full path of a very specific model that you want to use. But especially in the early days, we want to make it less intimidating, more accessible to folks. The second piece is, we really want to make performance easy, right? And so you shouldn't have to be an expert in, the accelerator stack in order to take advantage of the hardware that you have. So for example, if you don't have an accelerator, like it's, we think that it's like out of the box easy to use with RamaLama. So it'll do kind of like CPU inferencing. So it'll basically run it just purely against your CPU. If you do have an accelerator though, and you've installed the kernel driver, but maybe you haven't set up the other user mode drivers for your accelerator, or maybe it's not working, RamaLama will auto-detect that and choose the open source accelerator stack, which gives you pretty good performance. But then of course, like if you kind of were able to get past the the scalpers and afford the thousands of dollars for a GPU, right? You want to be able to take maximum advantage of that hardware that you purchased, right? And so if the accelerator stack is kind of all set up, then RamaLama will lean into that and pull in the container that's vendor specific with that stack to make the maximum use of your hardware. So all this happens under the covers, and you shouldn't have to think about it. So you can just kind of get up and running quickly. So as you're experimenting, right, you may be wondering, well, I feel kind of uncomfortable with this. I think there's kind of there, rightly so, is maybe some like questions or skepticism about like security in this space, right? Particularly around your data. And RamaLama kind of has two main ways that it addresses this. The first is, as I mentioned, it's local, right? So you're not giving your data to a cloud service or an AI as a service, right? Where you don't have to wonder, like, are they taking that data and doing something with it? That's the first piece. But the second piece is that because RamaLama is built on containers, what that means is that there's tighter control and isolation of the workload. So you can actually explicitly control the privilege levels of the application itself that's running the AI model, and also tightly control and explicitly control if it has any access to the external network, right? Which I think is really powerful. For those who are kind of familiar with this space, a lot of people kind of question about AI, like, oh, is it going to become Skynet, right? Like Skynet from the Terminator movies, where it's like it becomes sentient and like kind of takes over the world, right? I like to joke that like, we can thwart Skynet by keeping it in a container, right? So keeping it isolated and in a container, and it won't ever get out. And the Terminator movie never happens. Okay, so RamaLama is, we really lean into open source here. And what that really means is that, there's kind of a lot of different standards, a lot of pieces of the stack that are constantly evolving and emerging. And we want to give kind of maximum choice to users in this space, because we know that what existed in this space 2 years ago is not kind of what exists today. And what exists today, in a couple years, probably will be different from a couple years from now, right? And so with RamaLama, we enable that modularity where you can kind of swap in and out these pieces, supported by the community, and therefore you can use kind of different blocks depending on what your needs are. So what this means is like you can access the OLLAMA model registries, Hugging Face model registry, OCI container registry, or something that we don't know about yet, right? And then similarly with the inference runtime, you can use Llama CPP or VLLM or Whisper CPP or some other inference engine that we don't know about yet, right? That will emerge in the coming years. So, so now so you've experimented, great, and it looks good. Now you want to build an AI-powered application. What might that look like with RamaLama? Well, with RamaLama Serve, you can serve the model with standard APIs. So today, that is, a lot of the industry has kind of started to coalesce around OpenAI's REST APIs. And these are kind of a standard set of APIs that people use to kind of engage with the model, model API endpoints. And then in the future, we're looking to integrate with Llama Stack as well, which will, basically connects the front and back ends together and will make the integration of an AI application even easier. So that's something that we're looking to in the future. And then if you're building this application, you want to be able to get to production, right? Well, RamaLama can automatically generate a quadlet for you for single node inferencing. Or if you're trying to get to Kubernetes, it will generate the Kubernetes YAML file for you so that you can get to Kubernetes really easily without having to be an expert in this space. So now I'm just going to kind of go through a really quick demo that I had put together. And it's a scripted demo, so you don't have to watch me fumble through typing the commands. So all right, let's see if I can expand it a little bit. Maybe that's a little bit too large. Okay. All right, so you can see I'm running version 0.6.2 of RamaLama. This is actually a virtual machine of Red Hat Enterprise Linux version 9.5 on my MacBook. You could obviously run this on Mac, but we're at Linux Expo, so I wanted to show it on Linux, right? And the first thing that I want to show you is, so this is the configuration of RamaLama. You can see that I'm running it on an ARM64 CPU. And what I really wanted to kind of point your attention to is, you can see at the bottom over here, it's using this image, which is from Quay.io. It's the default RamaLama image. The runtime is Llama CPP. And this is the directory that it stores basically any models that you may pull down from. So it's my local directory. It's using a container, so use container is true, and the version is 0.6.2. Okay, so next, I'm going to show you really quickly, and hopefully the network holds up for this, is I'm going to pull a model from the OLLAMA model registry. So I'm going to delete it first so we know it's not there. And then again, hopefully the wireless holds up here. Let's see. Not bad. Okay, so it's going to take 5 seconds. Great. So we're pulling this model, which is called small m or small LLM. It's 135 million parameter model. Just something really small, right, where you can just really quickly try it out. Of course, I think most people are going to be pulling models that are larger than this, probably in the billions of parameters, but I don't think you guys want to sit here for the next 10 minutes watching me download it. So we're going to use this small LLM. 135 million. And then you can see with this command RamaLama ls, you can see, or RamaLama list, you can see that we pulled it from the OLLAMA model registry 27 seconds ago. It's 87 megs. Pretty straightforward, right? And you can see that, what am I running? I'm running this, the default RamaLama image, as I had mentioned, right? Okay, so next what I'm going to do is, I'm going to show you, take you behind the curtains and kind of show you the underlying command that RamaLama is running. And the reason why I want to show you this is because I think it kind of illustrates what I described before about the value of containers for RamaLama. So first and foremost, you can see that the command is Podman, right? It's using the Podman container engine. And the second is it's running that default Quay.io RamaLama container. The next thing I'm going to show you, and again, these are all the same command, and I'm just highlighting different portions for you to see. The next one is you can see that in this command we're basically keeping the privileged or the privileges to be very low. So basically, not giving the container many access or privileges to the local system. And then finally, with this -- network none, it really doesn't even have access to the external network. So I think just more assurance that hey, if you're very sensitive to data privacy, security, kind of wonder what this may be doing to your machine, have the confidence that it's in a container and it's isolated. So next I'm going to run the IBM Granite 2 billion parameter model real quick. And so I mean, keep in mind, this is running on a VM on my MacBook, right? So like this is only using that hardware. And I mean, you can see, just type a simple hello. Like it performs like pretty well. It's not bad for a 2 billion parameter model. For a lot of folks, again, you may want to use, depending on what your hardware is capable of doing, you'll probably want to use a larger model. But for the sake of this demo, I think a 2 billion parameter is enough. So next, we're going to convert this into OCI content. And so you'll see, ran that RamaLama convert command, and then you can see that, there's a new image for this small LLM, created just moments ago, right? The next thing we're going to do is we're going to generate the Kubernetes YAML file. So when you want to go to that kind of like scaled, production deployment, making it really easy to do, right? And you can see here, this is the Kubernetes YAML file. So next, I'm going to show you how you can basically create a quadlet for creating a single node inference server, and these are just basically the artifacts that you would need for that as well, right? This is the volume file, the image file, the container file. Yep. So that's it for the demo. So we really think that like with RamaLama, it's a really great tool to be able to experiment with these LLMs. Like you can try it out really quickly. But what I hear a lot from folks, and when I observe kind of how people's AI journeys in their organization, I think what we find is that out of the box or like stock AI models oftentimes aren't good enough. And you probably need to inject it with some of your own company's data. You probably need to fine tune it. And so, we really think that with a product that Red Hat is working on called RHEL AI, that makes that really easy to do and performant to do. RHEL AI is also a really great product for production level inference as well, because it embeds VLM, and I think we'll over time we'll be looking to provide optimization. Some of this optimization can be really important because I think I was in one of the talks yesterday. I was basically saying with VLM you can see like I think it was like 10 to 20x improvement in performance with VLM. And so, whether it's for, the end customer experience or, trying to make the most of the investment in the accelerator hardware that you already have, this sorts of performance benefits can be huge and be a make or break deal. And so that's where RHEL AI does really well. And then as you go to scale, we really think that a product that we're working on called OpenShift AI, which is an enterprise-grade MLOps platform, is a really great tool for that. So you basically modify your model, iterate, monitor, and scale it. And so these kind of provide an enterprise-grade platform for doing that. Where are we going from here? Again, we started from running the model, and that's like a great first start. We're rapidly looking to integrate things like being able to use your data as context. So for example, being able to give it PDFs or documents to the model itself, and then ask the model questions against those specific documents. Because I think that context is really important and matters. For those who are familiar with this space, that's people refer to that as RAG, or retrieval augmented generation. And so like this capability of being able to use your actual data and ask questions against it, we think is really powerful. So that's coming very soon. And then moving forward, we're looking into stuff like integrating function calling capabilities, so the ability for the model itself to call functions. And broadly, this is kind of like this idea of agentic, which is like, how do you let the the model be kind of autonomous and help you to autonomously execute tasks for you, right? So that's kind of more in the future. Finally, I think there's a big conversation going on about AI and what does it mean to be open source in this space. I know that there's probably been like talks at this conference. You probably heard about it in the media and the press as well. And there's a lot of questions about like, okay, well, the source code is available, but what about the data that was used to train a model, or the weights that you need in order to be able to, like that are actually kind of like the meat and potatoes of what allows the model to do what it does. And with RamaLama and with AI in general, like RamaLama and our team, we really want to lean into the open source way as much as possible. We are really excited about community contribution, and so we kind of readily accept that sort of contribution to the project. We just started in June of last year, and we already have, I think, and now it's like actually more than 1,300 GitHub stars, more than 50 contributors, and it's just been half a year. So we're really excited about where this is going to go. So we have, as I mentioned, a GitHub page, website. The QR code is for our Matrix channel where we have our community conversations. So we'd love to have you guys join the community. Check us out, contribute, download it, try it. We'd love to see RamaLama kind of deliver a lot of benefits to folks. So that's it for my talk, and I'd love to open it up for any questions that you may have.
Thank you, everybody. Let's go ahead and give him a round of applause. James, really appreciate you being here. Do we have a first question?
Yeah, so earlier you mentioned that specifically RAG integrations were coming very soon. So I was kind of wondering what type of approach you would take to that, because right now there's a lot of different sort of open source and like some closed source options for running RAG models. So for example, you have like ChromaDB to like vectorize your data and all that. So under like sort of container model, would you have like the actual RAG database inside the same container, or like how would that really work? Because obviously for us, we want to be able to, like that flexibility to run whatever model we want. But if that's kind of constrained to the database as well, then I could possibly see like some kind of issues with that. So what, I guess what approach would you guys really be going for here?
Yeah, that's a great question. And I'm not that familiar with like specifically the implementation details of like how we're going to do it. I mean, we have looked at kind of a number of like open source, like RAG mechanisms. But I think, what is our goal for RamaLama? It's really to kind of give you the ability to like try it out quickly. And so, we actually have kind of like a homegrown solution that we're going to put in there, just just like make it really easy, right? So you can just try it out like quickly, and then of course, like I'm sure that you probably already even have like ideas about like a more sophisticated way of doing RAG, and certainly we want to like let people do that. But like at a first step, it's like, yeah, I just want to like see what I could do if I have RAG capabilities here, and so we have that kind of like homegrown solution just to be able to try it out. Yeah.
I see. Thank you.
I was just wondering whether there's any possibility if I run the models locally, can I get my GPUs from my MacBook to be used by Podman and the models?
Yeah, that's great. So is your question like, can I use the hardware acceleration that exists in my MacBook? Is that your question?
Yeah, exactly.
Yeah, so we're actually working on that right now. Is like, how can we get that like GPU pass through to work? Like I think one of the cool things is that like, and we actually have a lot of kind of expertise in that in-house, and so like we're just kind of working through that. well, I think what's cool about that space also is that you can then lean on like kind of the open source accelerator stack to make like to further accelerate it. So more to come. Yeah, I think we're actually really excited about that because we know that a lot of folks do that like development and like want to be able to try it on their MacBook, and so we want to be able to make the hardware as performant as possible. So absolutely.
Yeah, that would allow people to actually try out the beefier and bigger models.
Yeah, yeah.
Because if you don't have GPUs, then, well, you're out of luck.
Yeah, yep, absolutely. Yep.
Okay, next question. Don't be afraid, we have time.
Yeah, so just like one more question. For RamaLama specifically, is there any specific benefits of using RamaLama as like a full stack compared to using something like Docker and then having like a internal, like in that image, dependencies for that model? So is there any like benefits to doing it like the Docker way or like doing it like the RamaLama way?
Oh, I see what you're saying. Like, could you just kind of take the pieces that already exist, or like assemble it yourself and do it in Docker, as opposed to like RamaLama? I mean, certainly you can do that, right? Like if, and I think like that's where like like the Linux ecosystem, like the container ecosystem is like really great because you can always piece it together, right? But we don't think, at least my opinion is that like, especially in the early stages, like, do you really want to go through that exercise of like having to assemble it yourself? Like that's where RamaLama I think is really great. And certainly it's not going to fit every use case, right? It's not going to be perfect for everybody's like needs. And so like where you have more specific needs, you can definitely go and like Docker compose it yourself, or like use Podman to compose it. I mean, keep in mind RamaLama does you can choose your container engine, so it can be Podman or Docker. Like if you want to containerize all of RamaLama, that's great. Really easy. If you want to kind of customize too, that's great too. Yeah.
I see. So would you consider like RamaLama more of like optimized for like ease of use over over kind of flexibility, if that makes sense?
Yeah, I would say so. Yeah. I mean, I think there is like some degree of flexibility, but it does at the end of the day have to be like opinionated in some ways because we're pulling specific container images that have already been kind of pre-assembled to make it easy. So I think from that standpoint, certainly, yeah, like I would say so that we're trying to make it easy, and so like full scale configurability is like sacrificed maybe a little bit.
Right.
Yeah.
Right. Okay.
Yeah.
I see. Thank you.
Yep.
Okay, anybody else? Other questions? Okay. Well,